Hi ladies, this is continuing on chapter 7. This is about similarity, and this lesson uses a lot of real life examples to show how you can use similar triangles to determine measurements. So we've already been looking at measurements for similar triangles based on proportions. And in this lesson, we're going to use indirect measurements, which is using similar triangles to calculate unreachable heights. So we're going to go through a lot of word problems, and in some of these there are diagrams provided. Sometimes you'll be asked to draw your own diagram. If there's not a diagram, I highly suggest that you sketch one out. It doesn't have to be pretty, it just has to kind of give you an idea of what you're looking for. So in this first example that you see on your note sheet, a person who's 5 feet 3 inches tall casts a 6-foot shadow. At the same time of the day, the lamppost casts an 18-foot shadow. What's the height of the lamppost? So we could actually go and measure this lamppost, or we can measure the shadow of the lamppost and know that the direction that the sun hits us is the same angle that the sun hits the lamppost at, if we're both standing up straight, which is perpendicular to the floor or to the ground. So this would be a 90-degree angle, and this would be a 90-degree angle. These angles are going to be congruent. So we know that this is a similar triangle because we have two congruent angles. So angle is a similarity shortcut for triangles. Now notice here in your diagram how it says 5.2 feet, and in the story it says 5 feet 3 inches. Get all of your units so that they are the same. So whether you convert everything to feet or to convert everything to inches, make it so that you are working with the same units. All right, so then our next goal is to set up a proportion. So again, you can either use a proportion within the triangle and compare it to a proportion within the other triangle, or you can set up corresponding sides. So I'm going to set up two proportions that are going to give you exactly the same answer for x. So the first one, I'm just using a proportion within this triangle. 5.25 to 6 is equivalent to x to 18. Or I can set up corresponding sides of the triangles and use a proportion that way. So then my second proportion is 5.25 to x equals 6 to 18. And both ways I'm going to solve for x by cross multiplying. So in this first example, my proportion using sides of the same triangle compared to same sides of the second triangle, I have 94.5 equals 6x, so x equals 18.75 or 15.75 feet, and 0.75 feet is 9 inches. And then for the next example, 15.75 feet is what you get for x, which is the same as 15 feet 9 inches. All right, let's look at this next example. Now this next example is just a similar triangle, much like what you've already seen. Pay attention again to your units. All these units are in feet. So we need to set up proportions to solve for x. So again, you can look at the proportion within the triangle and then compare it to the proportions within the other triangle, or you can set up proportions with corresponding sides. Okay, so I'm going to set up the two possibilities that you can use for proportions. The first one, if you're using the sides within the triangle, you have 12 to 5, and that proportion is going to be equal to this whole side, which is 12 plus 24, which is 36. So it's that whole side. It's not just the 24, it's the whole side. 12 plus 24 is 36 to x. Now, if you had the reciprocals of both of these, that's fine, but you would have to have the reciprocals of both ratio in order for it to be a proper proportion. Now the second set of proportions you could have would be comparing corresponding parts of the two triangles. So you could have 12 to its corresponding side, 36, is equal to 5 to its corresponding side, x. And for both of these, you're just going to cross multiply in order to solve for x, and you'll get the same answer. 12x equals 36 times 5, and 12x equals 36 times 5. 36 times 5 is 180, so 12x equals 180. In order to solve for x, we're going to divide both sides by 12, so 180 divided by 12 is 15. And same with the second set of proportions, 180 divided by 12 is 15. Again, make sure to include your units. The units here is feet. All right, now let's look at this next one. This next one does not have a diagram. So again, anytime you are not given a diagram, I suggest that you at least sketch one out. So first, read the problem and find out what you're looking for. So we have a large oak tree is 17 meters tall. I'll let you read it. I won't read it out loud to you. Okay, so let's start with our oak tree. So draw something to resemble a 17-meter oak tree. All right, so here's my 17-meter tall oak tree. And we know that it casts a long shadow on the ground below, and the shadow is 51 meters long. Okay, so here's my shadow, my oak tree, and this is 51 meters. Now at the same time, we have a statue.
Claire Key to A203. Claire.
Here's my statue. It would be of a person. And the shadow of the statue is cast at the same time as the shadow of the tree. And it measures 63 meters. Now my question is, how tall is the statue? So here's where it's helpful to have my triangles or my diagrams, because I'm going to use those to make triangles. So here's a triangle. And then here's another triangle. All right, so I know both of these triangles are similar because they have two corresponding angles that are congruent, because when the sun hits so here's my sun. When the sun hits the tree, it's going to hit it at the same angle as when it hits the statue. Okay, so those two angles are congruent, which tells me I have similar triangles. So now I need to set up some proportions. So looking at these two triangles, I can set it up two different ways. I can use proportions from the same triangle and compare it to a proportion from the similar triangle, or I can compare corresponding sides. So either way I do it, I can say 17 to 51 is equal to x over 63, or I can say 17 to x equals 51 to 63. So either way, I'm going to get the same solution for x. So I'll get 51x equals 17 times 63, and 51x equals 17 times 63. So either way I solve this, x equals 21 meters. So 1071 is 17 times 63, and 51 times x is 51. Divide both sides by x, so I get x equals 21 meters. All right, in this next example, just a concept that you should be familiar with before we get started with the idea of mirrors, is that if you look at a mirror, or if you think of any really kind of thing where an object would hit something and bounce off of it. In this lesson, we use several examples related to mirrors, but so let's imagine you have a flashlight, and this flashlight shines a light down onto your mirror. The light is going to bounce off the mirror and then continue to go up. So if anyone has ever used a watch to create a glare, that would be like a mirror effect. Now these angles are the same. So the way an object hits a flat surface, at the angle that it hits the flat surface at is the same angle that it's going to bounce off the surface. So that's an important concept for this lesson, is that any angle an object hits a flat surface at, it will bounce off at the same angle. Okay, so these two angles here, these are congruent angles. So now for this example, you know that these are similar triangles because they have two pairs of corresponding angles. So let's look at this next lesson, or this next example. Here's a mirror. So take a second to read through this, or pause the video while you read it. But here's our mirror between Samantha and this apartment building. And she's going to stand so she can look at the mirror. And while she's doing that, she is 1.22 meters away from the mirror. And also the mirror is 7.32 meters from the building. So if you look at the dark blue mark right here, this is the line that her eyes travel. They travel to the mirror. Her line of vision goes to the mirror, and then it bounces off the mirror and goes into that apartment building. And then that teal mark, this measures that she is 7.32 meters from the base of the building. Now we also know that her eyes are 1.82 meters off the ground. And now the question is, how high is that window? So we are looking for this height right here, the height of the window, and maybe it's actually the other window. Let's just adjust this. It's probably actually looking at how high this window is. So here's her line of vision. And just the orientation of the diagram is a little, it's not perfectly straight on. That's why the triangles don't look similar. But given the fact that she's looking into a mirror and it's bouncing off, we know that these two angles right here, this angle and this angle, are congruent, and we also know that these two angles are both 90 degrees. Now they may not look like it in our diagram, but that's just the way the picture is drawn. So we know that these are similar triangles, and we are looking for x. We're looking for the height of this building. And you can call it whatever you want, but that's the variable that we're looking for right here. So now we need to set up a couple proportions. So you can either, again, use proportions within the triangle and compare it to proportions within the second triangle, or you can match up corresponding sides. So I'll, again, do it both ways. So if we look at a proportion within the triangle, we have 1.82 to 1.22, and that equals x to 7.32. Or we could do corresponding sides, so that's 7.32 to 1.22 equals the proportion x over 1.82. So now when we cross multiply, in both cases, we're going to get the same thing. 1.22x is equal to 7.32 times 1.82. And 7.32 times 1.82 is 13.3224. You can round. Right now they have the nearest hundredth, so let's keep that. So 13.32 equals 1.22x. And again, just make sure that you include your units. So 10.92 meters is the value for x. So that's the distance from the ground to the window. So please jot down any questions you have about either setting up problems, drawing diagrams, or finding similar triangles. And we can address them next time I see you or in class. Thank you.